Hello everyone and welcome in today's video. Today I'm going to model the previous question which we explained on the last video, and I will try to model the question in Autodesk Robot, and after that in the end we are going to check and compare the results what we got with the hand calculations and compare them with the finite element method software. So let's start a new project. And again, as on the previous exercise, we need to choose this frame 2D design. I just press now on that. And as a first step, what we always do is to start modeling the shape of our frame. And to do that, we assign a member. And the member for this type of exercises, it's not that matters much, because we only want to check the results in the end for the reactions. It's not that we are doing some kind of designs and checking if the profile or the member has enough capacity to carry the loads and perform. So for that reason, let's just go with this automated member section from the software. And again, in our exercise, it was given that these are parametric, meaning this length from A to B is to A and length from B to C is A. And in order for us just to compare the hand calculations results, in the end, we mentioned that we have taken these values. We taken A as 5 meters and to A it will be 10 meters. Therefore, to continue our modeling on the robot, we can take this value so we can compare the results in the end. And as you can see, this is the member length, which is 10 meters. And the other one, as mentioned, it's going to be A, which is 5 meters. And as you can see, the endpoint coordinates, it starts at x equal with 10 meters and it will end at minus 5 meters, which basically it would be the length of 5 meters, as we can see here. So after we do that, the next step to be done is to add the support conditions. And we had on our exercise that we have, okay, let's just go back again. Yes, we have a pin here and a pin here. So to add a pin support which is rotated in that direction, actually for the support reaction it doesn't matter that much, but if one wants to have that support reaction rotated like that, we can change the direction of it, and it says on Y, and basically the positive direction is going to be this way, and we have 90 degrees, and we can name it different, rotated, for example, 90, and we can add, and after we have this pinned support, then we can add it here, and as you can see, this support reaction is rotated. For the other one, we have a pin connection here. Okay, let's just quickly check. Yes, this one must be 0. And now we add this one, and we have the pin support on this part. So now the structure is stable. We define the members, we define the support conditions, and the next step before adding the loads is that we have to add the load cases. So let's start with the first one, which is the dead load, which we can say that it's a vertical load, and we can add it. So after defining the structure and after placing the right support conditions, the structure is stable. And now the next step to be done is, before adding the loads on the members, we need to define the load cases. We go here, we press, and we have to add, let's just name it dead load for all the loads acting on the member. It's not that it's very important. As for this purpose, as for this exercise, we just need to find the support reactions. We click add. Now we go to the load definition, we go to member, and we click uniform load, and as it was given from the exercise for member AB, we have minus 10 kilonewtons per meter acting downwards. We just click add. And next, if we want to add the wind load, which for this exercise was acting on the opposite directions of x axis, as we can see from here. Now we put 0 on the vertical direction and we put minus 5 if I'm correct. Let's go to the end. Yes, -5 kilonewton per meter. We just add this load, and now we will have our system which is completed. So now we have to run the analysis from this button here, which says calculations, and it will take a moment. And now the results are available, as can be seen from here. And as on the previous exercise, we have to be careful because the software takes into account also the self-weight of the members. And in order for us to remove that, we just click here and we cut. So the analysis will not include the self-weight of the members. For example, the profile has some weight overall. So now we go again to the start. Now we run the analysis again. And now if we want to compare the results with our hand calculations, we need to display their values. But basically these are the values which we got from the hand calculations. And now let's check with the software. We go to the results, we go to the diagram for members, and we have the reactions tab here. And what we are interested is the reactions on X and Z directions. We do not need those on Y directions because there are two support conditions, which are both of them are pinned, and as we know, pinned connections are free to rotate. So basically their value will be 0, so there is no need to show them. Important to mention here is that this button must be on, which has the descriptions to show their values. And here we have the results. So we have the f of x with this value, fz, which in our case exercise it would be ax and ay, and the same thing for the other support conditions. So this was the video for today. I really hope you enjoyed today's video. If there is any question, please leave them in the comment section below. Leave a like, share, and subscribe to our channel for more content. See you on the next video.